Hi class. So we continue our study in chapter 4 talking about triangles and congruence by moving into section 4.2 and talking about congruent figures. All right, so we have two objectives in this section. What we want to do is we want to identify corresponding parts in congruent figures. Well, we'll start by actually talking about what it means to be a congruent figure. And then the last thing we'll do is we'll prove two triangles are congruent by using some of the theorems we've already discussed in this class. All right, so let's start with the definition. So congruent figures have the exact same shape and size. So all the figures below are congruent. So as shown, what we have below is a flip, a rotate, which is a turn, or a slide. These things do not affect whether figures are congruent because they still have the same shape. So this is my first figure. All I'm doing is flipping it over here. All right, still a congruent figure because they have the same shape. Now I'm just rotating it a little bit, still the same shape. And now I'm sliding it. So even though it has a different position, basically it's still the same shape. All right, so when figures are congruent, their corresponding sides are congruent and their corresponding angles are congruent. So I have these two triangles here. I have triangle ABC and RTS. Well, notice here that they're just basically a flip of one another. So what this is saying is angle C is congruent to angle T, angle B is congruent to angle S, angle A is congruent to angle R, and then so on. So side CB is congruent to TS, AC is congruent to RT, and AB is congruent to RS. All right, so corresponding angles and sides, I told you the angles right here, and then I told you the sides right here. All right, so let's talk about naming congruent parts. So for the two figures, we are given that we have this figure ABCD is congruent to TRQS, right? And notice how you can tell which sides are the same by their colors. So the figures help, but having the congruent angles listed in the corresponding order is also needed. So if I know that a figure ABCD is congruent to TRQS, angle A here is congruent to angle T, angle B is congruent to angle R, angle C is congruent to angle Q, and angle D is congruent to angle S. And then finally, the sides are congruent. So AB is congruent to TS, BC is congruent to RQ, CD is congruent to QS, and finally DA is congruent to ST. So all I've done is I have two congruent figures, and I've just listed their sides. All right, so here's another example. In the process of folding an origami cat, which we have down here, two congruent triangles are formed. Right, so we're given that the triangles A, B, and C is congruent to triangle A, E, and F over here. So what I want to do is find the measure of angle F right here. All right, so how would I do that? Well, the first thing I need to do is note that angle C is congruent to angle F because they're congruent figures. So if I find angle C, I'll be able to find angle F. Well, the way I'll find angle C is I know from section 4.1 that the interior angles of a triangle must sum to 180 degrees. So if I take measure of angle C plus 96 plus 36, it should sum to 180 degrees. So just adding these and subtracting, the measure of angle C here is 48 degrees. So since triangle ABC is congruent to triangle AEF, measure of angle F, what I'm looking for, is equal to the measure of angle C, and it has to be 48 degrees. All right, so a theorem, third angle theorem. If two angles of one triangle are congruent, so like angle A here is congruent to angle D, angle B is congruent to angle E, right? Then the third angles are also congruent. So it must be, if two of the angles are congruent, that angle C is also congruent to angle F. It just has to, no other, can't happen if the other two angles are congruent. All right, so let's do an example here. So the first thing I want to do is I want to find the value of X. Now you have to be careful just looking at this. Angle J is congruent to angle R. Angle H is congruent to angle S. So I'm trying to find this angle right here. So to do that, angle Q must be congruent to angle K. So I have to find angle K first, right? So thus from the third angle theorem, what I see here, just as I said, angle K must be congruent to angle Q. So using this first triangle, triangle JHK, let's find the measure of angle K. Well, it must be that the interior angles sum to 180 degrees. So the measure of angle K is 180 minus 53 minus 92. So the measure of angle K here is 35 degrees. Well, then since the measure of angle K is congruent to or equal to the measure of angle Q, 35 degrees is equal to 10x plus 5. Subtract the 5 over, divide by 10, and we get that x is equal to 3. So the value of x, which I was looking for, is 3. So to check, let's replace x with 3 and see that 10x plus 5 is equal to 35. And then we make sure that if 35 plus 53 plus 92 sums right back up to that 180 degrees, which is what we wanted. All right, let's end this lecture talking about a proof. All right, so I'm given here that segments LM is equal to LO and MN is equal to ON. So I've got that these two sides, this side and this side, and this side and this side are congruent. And then what I also see is the measure of angle M is equal to the measure of angle O, and that the measure of angle MLN, so this right here, is equal to the measure of LON, OLN, my apologies, OLN. So what I want to do is prove that the triangle LMN is congruent to triangle LON. All right, so to do that, remember, congruent figures must have all the same angles and all the same sides. So what I must show is that this interior angle here is congruent to this interior angle, and that this side of the triangle is shared is equal among both of them. All right, so I'll start with do a column proof here. So I'll start with what's given. All right, that LM is congruent to LO and MN is congruent to ON. The next thing I'm going to do is I'm going to say that segment LN is congruent to segment LN. All right, and that's the reflective property of congruence. All right, so that's just saying that that third side of each triangle, two separate triangles, is congruent. Next thing, I'm going to say that the measure of angle M is equal to the measure of angle O, and the measure of angle MLN is congruent to the measure of angle OLN, and those were given. Well, then it must be that the measure of angle MNL is equal to the measure of ONL, right? So those two interior angles must be congruent, and that's by that third angles theorem that we've been talking about. So now what I've proven is all the interior angles are congruent to opposites of each other, and then the three sides are congruent to each other. So then it must be then that triangle LMN is congruent to triangle LON, and that's by the definition of congruent triangles, because all their corresponding sides and corresponding angles